Okay, hello everyone. Let's go through this practice exam and just cover some pointers. As always, email me if you want any more detail. So number one, we're trying to find the center and radius, and we're given an equation. We need to do this double complete the square process. So notice what I'm doing here is I'm separating this into x and y terms. Here are my x terms, here are my y terms. I have a 45. I go ahead and subtract 45 from both sides to take it over to the right side. And notice when I actually write this line, I don't know these numbers yet, and that's why I put those underlines there. I drop down to the next. I'm looking for a perfect square. So I split this negative 12 in half to get this negative 6. Then I know that in order to get a perfect square of x minus 6 squared, I really need a plus 36 back here in the original. I'm kind of thinking backwards. But if I add plus 36 here, I add plus 36 here. And just as a note, remember if there are any numbers being multiplied by this entire set of x terms, when you add the number to the right side, you need to take whatever number is in here multiplied by whatever number is being distributed to the entire quantity. Okay, so once we get that, we put it in this form, and here it's just a matter of knowing that what gets subtracted from the x is your h, what gets subtracted from the y is your k, and then this is your radius squared. So take the square root to get 4. Okay, so this one already is in pretty nice form. If it wouldn't be, just go ahead and put it in this form. Complete the square to get your x, perfect square x over here, and then factor out whatever coefficients on the y. And the vertex you can pull out right away by seeing that what's getting subtracted from the x is -1, what's getting subtracted from the y is 7. In order to get beyond that, it's nice to draw a little visual. So once I have that vertex, I plot it, and then I ask myself, is it opening right and left or up and down, up or down? And since I see that the x term is getting squared, not the y, I know it's going to open either up or down. Since I see that this is a positive number here, I know it's opening up. So I go ahead and draw that, because that tells me roughly where the focus and directrix is going to be, although I still need to know how far away to go from the vertex. And that's where I look for the p. So I know that 4p equals 8. Solving for p, I get 2. So if I go 2 up from the vertex, I get the focus. 2 down, I get the directrix. All of that is contingent on the fact that this parabola is opening up. If it were opening to the right, I would have gone 2 to the right to get my focus, and 2 to the left to get my x equals something directrix. Okay. So even though I asked for the sketch last, again, I would recommend you do it earlier on. Okay, the ellipse. One thing to keep in mind, this formula is always going to be the same. A squared equals b squared plus c squared. We just have to figure out if the major axis, if the b is actually greater than the a, or if the a is greater than the b, and it's more of a horizontal ellipse. Okay, so other than that, we're just plugging it into the formula basically. And again, to solve for that a, we need to use the fact that we already have the c, whatever the distance is from the foci to the center. And we have the b, because that's from the vertex to the center if b is greater than a, if that's the major axis. How do I know that that's the major axis? Well, because I'm given the coordinates of the vertices and the foci, and I know that they all line up on the major axis. So drawing that again, I can find that's the vertical major axis. Okay, so you could, with a system of equations, first of all, if you didn't get the version that had the -1, my apologies. That's what all this crossing out here is. I realized that I had put a 1 there by mistake instead of a -1. A -1 works out very nicely, and that's what I intended for you to solve, but I accidentally wrote a 1 there first of all. Now, you can solve these types of questions with the methods from 8.1, which is the triangle, or 8.2, which is this reduced row echelon form. I strongly prefer the reduced row echelon form. It's much easier. And to be honest, you would often solve this with a calculator or computer program, and all you have to do is type in RREF and then your matrix, and it will put it in this final form already. But at the same time, I think it's good to get the practice here, and certainly for the test you need to. So what I'm doing is I'm just doing operations on these equations, and by the way, notice that I put 0y there because there wasn't a y term in the middle equation. Okay, and then after this, I'm using all these different operations, many different ways to do this problem. This is just the way I chose. Basically, what you want to try to do, you want your first goal, you want this top left one to be 1. Next, you want to get this number to be 0, and I worked it out so both happen to happen in the same step. After I get that, I want this number to be 1, which is what I did. And then I need these two to be 0, this to be 1. After I get all that, then I change this to 0, and then I change these two to 0. And how I do that is just a combination of the steps. Remember, we're allowed to multiply or divide any row by any constant. We're allowed to add or subtract any row from another row. In fact, we can add or subtract any multiple of a row. So for example, if I want this to be 1, I could have just divided through this entire row by 2. Or I could have taken, well, that wouldn't be very practical, I guess, but I could take this row minus this row, and then rewrite that row at the top, because 3 minus 2 would give me 1, which notice is what I'm supposed to do here. So I'm just using elementary row operations, adding and subtracting multiples of rows to each other, or switching them like I did right here, until I get it in the reduced row echelon form. And then what this tells me is, going back, remembering that I changed this form to the matrix, I can also go backwards. In other words, this is 1x plus 0y plus 0z equals 1. Another way of saying that is x equals 1. Similarly, y equals 0, z equals -2. Okay, on any of these exact value, I would recommend drawing the unit circle and knowing a few things, knowing that my cosine is my x value on the unit circle, the x coordinate value, and sine is going to be my y. For doing these, I would recommend looking at it a couple different ways. Maybe draw a triangle, maybe if you have it memorized, and make sure that the two line up. If not, investigate further and figure out what was going on there. Okay, whenever you see find all the angles, or if you see find the exact answer, or really anytime you're doing a trig function, keep in mind that a trig function is this periodic function that's going, if we're looking at a graph of it, it's going up and down, which means that if we want, ooh, that wasn't good. So there should be a theta in there, sorry, I will get that changed too. So cosine theta equals negative square root of 3 over 2. And again, we know that this is the x value. Cosine theta is the x value. So when is x negative? Well, over here in quadrants 2 and 3. And then we set up the triangle to find out it would be at 5 pi over 6 and 7 pi over 6. But we know that we're going to get that same cosine value every single time we come around the circle, or if we went backwards. So basically, we're adding and subtracting rotations, complete rotations around that circle, because every 2 pi, we're going to hit that exact answer. 1 times 2 pi, 2 times 2 pi, and same for the 7 pi over 6. That's why we do need to include these parts in our answer. Okay, here we're told that theta is in quadrant 2. It's kind of going backwards. first of all, I would try to figure out what your triangle looks like, because then you can easily switch cotangent around. Cotangent is just going to be cosine over sine. We already know what sine is, and the cosine we could figure out because we know it's in quadrant 2, so we know it's negative. And using the Pythagorean, we know that this is 1, this is 4/5, and using a squared plus b squared equals c squared, we can find that this has to be negative 3/5. And just simplify to negative 3/4. So these are these annoying rules to memorize, but if you remembered either of these two formulas, so this is formula number 1, this is formula number 2, you could change it to what appears to be a sum. Now, I think this is what they were after, which is why I say maybe put this on the final. But arguably, here you've written cosine 7 theta times cosine 2 theta as a sum. So I think you would have good justification to say that either of these answers is correct. So be creative. If you don't remember the exact formula you need, try to figure out any other formula that might have this as part of the formula, like you see right here. Okay, following the period, really this is mostly just knowing about the translations, that this is a vertical shift. Here, this omega is whatever coefficients on the x, and this phi is whatever is being added to our x term. Then when it comes down to the period, it's just 2 pi over whatever our omega value is, so in this case 2 pi over 3. You do not need the rest of this for this answer. You would really only need this part right here. Well, I guess you would need to tell me what the omega equals. But I'm just showing you because obviously the test question itself won't look like this. You should know how to do this with sine or cosine or tangent also. Okay, these are kind of tricky. Arcsine of sine of an angle. You would think that they're just canceling each other out, and they are if this value is between negative pi over 2 and pi over 2. Unfortunately, this one's not. So first of all, we find out what sine of 5 pi over 3 is. And once we get that value, we work backwards and we ask ourselves, okay, well, what different angles would give us this negative square root of 3 over 2? So that would be really all these angles. However, that is not the final answer, because arcsine is only defined here if we're between negative pi over 2 and pi over 2. So out of all these lists of possible solutions, really there's only one here, negative pi over 3, that's within that specific interval. And so that's our final answer, negative pi over 3. Okay, and finally, this one's kind of a challenging question. And I'm giving it because we had this exact question in the WebAssign homework, so you should have already worked through it. Several different ways to solve it. My method would be rewrite sine and cosine as in the SOHCAHTOA form, opposite over hypotenuse, adjacent over hypotenuse. We know that in the unit circle, hypotenuse always equals 1, so we get these two equations, solve for opposite, plug it into the second equation. You could solve for adjacent, it really didn't matter. But you end up getting a equals 0 or a equals 1. The adjacent side equals 0. Where would that happen? Well, it's hard to know because we wouldn't really have a triangle then. But the adjacent side is going to be this length right here. So you could see that the limit would be this pi over 2 or 3 pi over 2, and, well, no, sorry, this would be a negative, whereas here we would have positive 1, here we would have the limit as negative 1. So really these two are the only two that would add up to 1 as we get closer and closer to these points.